No. Theta.
It's used
The beta.
resources.
All right. So yesterday we talked about sine, okay? And we said, so I'm just going to briefly go over the notes from yesterday. So we said that the original sine curve looked like that and went on forever and ever and ever, right? Okay. And then we inverted that. But the problem with that was when we invert it, let's see, we go up first. What's wrong with that? Not a function. So in order to make it be a function, we had to restrict our range. So now let me get out this one, that one. And so we said, no, 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 yep, like it, like it, like it, like it, no, 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 right? Okay, right? And yesterday we said that that restricted range then went from positive pi over 2 to negative pi over 2. And then we did a bunch of problems and we said, okay, so, it's used to find angles. And normally we put an angle into our trig function and we get out a real number. Well, now we're putting a real number into our inverse function and we're getting out an angle. And so we tried a couple. And then we got to that one where it was the inverse sine or arc sine, either one. I don't remember which one it was. We'll go with arc sine just because I think it's cooler. Of negative 1/2. And you guys all said 11 pi over 6. And I said, no. And you're like, yeah, it is. And they're like, yeah, it is. And I'm like, no. Okay? Okay? Because if we think about this, now we're in radians here, right? Well, we can easily be in degrees. So if I switch this over, this would be 90 degrees, right? This would be negative 90 degrees. And so the arc sine or the inverse sine has a range from negative pi over 2 to positive pi over 2 inclusive, or from negative 90 to positive 90 in degrees, also inclusive. Okay? Now I'm going to go over here to the window. Sorry, people watching at home. Okay? So if I go over here to the window and I say, oh, yeah, here's that arc sine of negative 1/2 right here at your 11 pi over 6. Right? But that's also 330 degrees. And it's 330 degrees in that degree. That's like 11 pi over 6 or 330 degrees. Gotta be negative 30 degrees or negative. Okay. Brad, you keeping you awake? Yeah. Sorry. You want to move Mason off the table and we'll just lay it on the table. You're gonna learn. Like that. If I had some kids, we're going to have to say
Where'd that get you, Jack?
Oh!
Whoa.
Snitches get a pan-fried butterfish.
Hey.
No, because it was his. It's actually his fish. It's actually his fish. Yeah.
Wait. Hold on. Did you buy the fish for the project, or is that like your pet fish? No, that's for the project.
Oh, perfect.
So you're just gonna water it every weekend?
Well, I actually had it for possession.
Yeah. Jack comes in every night and takes care of it.
Exactly.
Yeah.
Even better.
Yeah. All right. So now let's go to cosine. Let's do cosine. So we're gonna follow the exact same process. First thing that we're gonna do is we're gonna graph regular cosine. So refresh my memory from last chapter. We just took a test on it last Wednesday. What's the curve of cosine look like? Starts high. So let's start it at 0. At a 0 degree angle, are we high, middle, low? Cosine's up high, right? Okay, so we go up high first to start, and then we come down, and then we go back up, and then we go back down, and then we go the other way, down, down, and so on and so forth. Yay? Sure. So how high do we go? Regular? 1. How low do we go? -1. And then so when do we zero out? So this one. Pi over 2, right? When do we minimum out? 5. 3 pi over 2. Back up high at 2 pi. Okay, so backwards that would be negative pi over 2, negative pi, negative 3 pi over 2, and 2 pi. Right? Okay. So points that we would have would be like negative 3 pi over 2 comma 0. Negative pi over 2 comma 0. Pi over 2 comma 0. 3 pi over 2 comma 0. Oh man, I did, didn't I? Whoa, that's a bad one. That's even better. Okay? Better?
It's a bit too vague now.
Now, if I were in the hallway, I'd call you a bald-headed pimple. But I'm in class, so I can't. So technically, I should call you a bald-headed pimple. What? No, I was in the hallway, yes. I was walking away. I was going to finish my lunch. And, yeah.
Well, that's
So
a
one
bad
person
way
has
to
to be
put
in
it.
the hallway.
Yeah.
One person.
Yeah, so see, we don't fit the qualifications. So I don't think you're a bald-headed pimple. Because 1, you're not bald. 2, I don't think you're a pimple. I don't know. But I don't think so. Give my heart. All right, let's do the inverse then. So, invert. Yesterday we learned all about inverses. What do we do to do an inverse?
X equals cosine of y.
We turn it, but we do what?
X equals cosine of y.
Yeah, we got that. It's written down.
Yeah, you flip the X and Y.
We switch the X and the Y. Yeah. Okay. So we just switch the X and Y. Okay. Right. So when we go to graph it, oh yeah, graphics. Look at that one. This one has one on it. Wow. Wow. Okay. So when I go to graph it, so real cosine function, I go through the point 0, 1, which means inverse cosine, I go through the point 1, 0. We should like go here, like this is 1, and then that's -1, and then we should probably go right. So we go through the point 1, 0. Real cosine function, we went through the point pi over 2, 0. Inverse, we would go through 0, pi over 2. Real cosine, we would go through pi, -1. We go through -1, pi. Okay, so then back to here, we follow this pattern, and it's going to look kind of like this, right? It's like that slinky again. Right? But what's wrong with it?
It's not a function.
Not a function. McGurd. Okay? So, what we need to do is we need to restrict to make it be a function. Actually, hold on, tap the brakes. Let me go here. Okay. So what do we, so I'll get out the eraser and we'll go from there. Okay? Actually, no, hold on, tap the brakes. I won't get out the eraser. First, I'm going to save this one and I'm going to see, I'm going to do it over here. We'll do it on this one. Okay? All right? So, eraser's out. Here we go. You tell me when to stop erasing. Still stop? Still stop? Still stop? Still stop? Still stop. Right? Does that hit every value from -1 to +1? Okay. Including 0? Okay. Right? I like it. So we would have to, so inverse cosine or arc cosine is restricted to what? Yeah? I would agree too. Which means, where are we? Oh yeah? The top half of the unit circle. So sine is on the right half, cosine is on the top. All of the Yes, ma'am. Oh, that's a great question. Okay. So how would we get a third quadrant? We have to add, well, we have to add higher or get it back to in that range using our trig identities. Okay? Love it. So what I would like for you to do now is I would like you, see there was restricted range, I went ahead to one, I just put it all in one. What I would like for you to do now is I would like you to find me those 10 values. Okay? Right? Arc cos or cosine inverse, yep, same thing. Just like arc sine, sine inverse. Okay, number 1. So, in my brain, I'm thinking where on the top half of the unit circle, where on the top half of the unit circle is cosine square root 2/2. Pi over 4. Yep. Yep. Okay. Number 2, where top half of the unit circle is cosine Number 3, where top half of the unit circle is cosine -1/2. Pi over 3. Number 4, where top half of the unit circle is cosine -1. Pi. Right? You good, AZ, or not? Well, you said no when I said something. I just want to make sure. You need a clarification? More of an explanation? Stop yelling at me. Just trying to help. Next thing you know what she's gonna call me. No, she's gonna probably call me a balding blackhead. What is it? A pimple? No.
Wouldn't it just make you seem like you have hair then?
What?
Wouldn't that just mean you have hair?
I do have hair. I choose to cut it off.
Yeah.
Oh yeah?
You should go 2 weeks ago.
Missed it. Top half unit circle. Where is cosine -√3/2? 5 pi over 6? Ooh, that's bad.
6
I
Bad still. Madness all around. All right, number 6. Arc sine. Now where am I looking?
Right half.
Right half of the circle. Where on the right half of the circle is our phone out and texting we're texting mom, right?
Yes, sir.
Yeah, or you're on Snapchat, one of the other two. Okay? We're going with texting mom? Okay.
It was actually dad.
Oh, it's dad this time.
Yeah, it's his truck broke.
Okay. Right half a unit circle. Where is sine 1/2? Pi over 6. Yep.
All right, yeah, we're good.
Now, we're going to really step out. Okay? Next one is cosecant. Cosecant goes with
What?
which one? Goes with sine, right? Okay. So cosecant goes with sine. So my question, so this is really saying, where is, since I'm with sine, right half of the unit circle, where on the right half of the unit circle is the reciprocal equal to 2? Pi over 6. Okay? Pi over 6. Because this is really, we think of this as inverse sine of 1/2. Because cosecant is the reciprocal of sine. So if I hey, Siri, I'll tell you when I need something searched. Okay? Yeah, help us on the web. See? Going off now. Okay? So if I reciprocate 2, that gets me to 1/2. So that puts me back in sine 1/2. Yeah? Secant, inverse secant of -√2. Number 8. Secant goes with what? That goes with cosine. Okay? So I'm going to scroll down here a little bit in this one so we get a little more extra space. So this is inverse cosine of what? -1 over the square root of 2, correct? Because I got to reciprocate it. Well, that's not on the unit circle. So let's get it on the unit circle. Let's go -1 over the square root of 2 times the square root of 2 over the square root of 2, and that gets me negative square root of 2 over 2.
Got you. So it's pi over.
No, it's not pi over 4.
Okay, so it's 1 over 4.
Okay? It's 3 pi over 4.
Oh.
Because it's cosine and it's negative, which means it's got to be top half, whereas cosine equal to negative root 2 over 2 happens at 3 pi over 4. Okay, hard one now. Brad, I still haven't gotten to your 3 undefineds in a row yet.
Yeah, no, I realize my mistake.
Okay, okay. Now, just so you know, Mrs. Hill calls it not possible. Mr. Roth calls it undefined, and I call it both. So we hit them all. Okay? So you can put either undefined or not possible for one that doesn't work. Like number 9. Number 9 doesn't work. Okay? Why not? Okay. So if we reciprocate, right?
It'd be 2 over 1.
But what would the trig function become? The trig function.
Sine opposite.
It would be inverse sine, right? Or arc sine. Okay? And then it would be of 2. Okay? So it becomes, because cosecant goes with sine, everything needs a co. Okay? So cosecant goes with sine. Okay? So it would be arc sine of 2. Which is not possible because right half of the unit circle, where is my sine value 2? Nowhere. So not possible, undefined, either one will accept.
Wow.
Okay? Number 10. Right side, unit circle, because it's sine. Where are we? Negative root 2 over 2.
Tickets for the Winter Gala on sale until January.
No. Hold on. Back in it now. Right side, because we're sine, right? Right side of the unit circle, where is sine? Negative root 2 over 2. Negative pi over 4. Because again, it's gotta be, sine is that goofy one. It's gotta be in that negative pi over 2 to pi over 2 range. So this is negative pi over 4.